So hi, I'm Mark Talbot. I'm an architect in Appian Professional Services. I provide our customers with design guidance around application and infrastructure architecture. I've introduced customers to DevOps and various automated tools such as Fitnesse, the automated versioning manager, and the automated import tool. Shwetha?
Hi, I'm Shwetha Reddy. I'm a product manager at Appian, and I'm responsible for features that make applications easy to build, deploy, and test. Prior to my role at Appian, I was a programmer and an IT lead in telecoms and IT services industries.
Great. So I want to start out with a deployment story, and perhaps people in this room can relate. I'm assuming that's why people are here. So I was on conference call late at night. There were several members of the IT organization on this call. We had representatives from the database team, the application server team, the Appian team, and the test team. The call even went on into the morning. We ran into issues with the deployment. We found out that there was a database script that wasn't run. So, okay, it's 4 in the morning. We've got to find a DBA with production access that can run a database script. We get the database script run. We then import the application, import successfully, but then we have to find a test team that can do our smoke testing for us. They go through the smoke testing. It's 7, 8 a.m. on a Saturday. We were up all night, and we had a very painful deployment, and you can guess we do very few of these painful deployments. So this is the problem we're trying to solve with the automated deployment tools. So too often, delivery is like a traffic jam. And what I mean by that is you have a developer that completes a set of functionality, they export their application or patch, and then they manually import it into the test environment. Perhaps they find out that there's missing precedents, they have to go back, recreate the patch, import it again. This is the traffic jam. It's kind of unpredictable, it's disorganized, it's slow, it's frustrating. And then once you import it to the target environment, you have to do a set of manual smoke testing. And hopefully you catch everything. Otherwise, you're going to have regressions. Testers are going to open up defects. And you're going to be focusing on old functionality. You're going to be focusing on regressions and not new functionality. So the argument I have for today is, instead, delivery should be like a subway. It's repeatable, it's reliable. The same process and procedure I follow in my test environment, I should follow in higher level environments. And this is how I argue it should work. A developer works on a set of functionality, they export the application, but instead of importing it directly into the target environment, what I want the developer to do is I want them to commit that to version control with our version control tool. I then want a tool like Jenkins to automatically kick off based on the change in Git. You can set up Jenkins to monitor Git for changes and then build an application package with the version control tool. You can then have Jenkins inspect and import that application. Furthermore, you can have Jenkins kick off automated unit test. You can have it kick off automated functional test with Fitnesse. And then you can have it even kick off automated performance test. This is a more repeatable and reliable process. And you can follow the same process for your higher level environments. So let me walk you through the agenda. First, Shwetha is going to give us some background on some existing functionality in the product and some new functionality in the product and how you should use those tools within your organization. Next, I'm going to tell you how to get started. What I'm going to do is I'm going to show you an end-to-end demo with Jenkins on how you can automate your deployments with any CI tool, really. Jenkins or Bamboo, it doesn't matter. Lastly, what we're going to do is we're going to take you through a set of frequently asked questions. So we get the same questions all the time. We're going to ask you, or we're going to tell you those frequently asked questions, and then we're going to leave some time for Q&A. Sure.
Thank you. So before we talk about how DevOps works with Appian, let's address the industry-wide definition of DevOps. DevOps is a set of processes and tools that automate the processes between development and operations for you to build, deploy, and test and release into production faster and in a more reliable way. It incorporates the agile and lean approaches currently in deployment into operations as well. At Appian, we use the DevOps approach by including the needs of operations into the process early on. For example, continuous monitoring and shorter feedback loops. The collaboration between the two teams improves productivity by automating the workflows and continuously monitoring your application for performance and quality. We will then talk about continuous delivery, which is a core piece of DevOps. Continuous delivery is a DevOps software development practice where design changes are automatically built, tested, and prepared for release to production. It basically combines the concepts of continuous integration, automated testing, and continuous deployment. It is your ability to have changes of any kind, whether it's new features or bug fixes or configuration changes, to be released into production faster and in a more sustainable way. And you can achieve this by ensuring that your code is always in a deployable state. We will now show you how we implement this DevOps practice when working with Appian. We're going to walk you through how we're going to integrate DevOps with Appian through the 4-step process of the build, deploy, test, release cycle. And for the purpose of this presentation, we will be building on the survey application, which is available on the app market to download. The survey application allows designers to create customizable surveys and add business logic to it to suit the needs of the hour. We will be building a decision table on the survey application, and then we'll take you through the process of building a patch with these changed objects, and then show you how we use automation tools to deploy and test these changes into your production environment. Automation is possible only if you're continuously integrating and continuously deploying. Continuous integration is when you have a group of developers continuously checking the source code into master. Continuous deployment is when you're continuously deploying to higher level environment. And together you get continuous delivery, and they all make up pieces of DevOps. So let's dive into each of these processes, starting with the build stage. What you see here is the survey application. The designer can come in, create a new survey, add the name, instructions, as well as decide on the number of questions and the type of questions. The highlighted portion over there helps them decide on a survey deadline date. Now the designer needs help with calculating an optimal deadline date, and we are going to be creating a decision table to help him make that decision easy. So what you see here is a decision table that was created using the Appian Decision Designer that was released in 17.2. The decision calculates the days to the deadline by taking in 2 input parameters: the day of the week that the survey is being sent and the number of questions on the survey. So more questions would mean longer survey deadlines. For example, if the survey is sent on the Friday or the weekend and you have 3 questions or less, the suggested days to deadline would be 6. And if there are no input passed, the default is 1 week, versus if there are no days of the week passed and the number of questions are 8 or less, you automatically assign 2 weeks as a default. So at this point, I have created my decision, I have tested that it works, and I'm ready to build my patch. In 18.1, we introduced persistent patches that allow designers to build incrementally and as you go. We recommend you do so because, when the time comes for you to deploy, you already have your objects in the patch ready to be staged, saving you time and the additional overhead from keeping track of all these objects. So at this point, I'm going to select my decision and the interface that's calling the decision, and I click on Add to Patch. Another useful tip is when you have your objects already in your patch and you're making changes, you continue to make changes to those objects, the patch will always reflect to update the latest version of those objects. So at this point, I'm ready to export and download my package. As I mentioned earlier, patch contents persist even after you export your package. So for any reason that you have any errors that you encounter, you can always go back and your patch persists. In that way, you don't have to build your patch all over again from scratch, because there are times when your patch might have large set of objects. So you're saving a lot of time by doing this. So now that we have exported the package, we're ready to deploy to your target environment. We're going to show you how to automate this process using the automated deployment automation manager. The deployment automation manager consists of two tools: the automated versioning manager that's responsible for change management for Appian applications, and the automated import manager that automates the application deployments. Together, you have the deployment automation manager, which is available in the app market for you to download. Also, the two tools can be used in conjunction, or they can be run independently. So the automated versioning manager is a tool that allows a group of developers working through their sprint cycles to consistently add the newly built content into a version control system. An external CI tool like Jenkins would take this content, build your application package, and then feed it into the automated import manager, which will consume it and import it into your target environment. The automated import manager supports the deployment of application packages, and in our case, the patch packages. Also, import customization files if designers want to use environment-specific constants, as well as database scripts and any admin console settings. You can kick off this tool either from the browser or from a command line. Alternatively, like I mentioned, Jenkins can kick off a job that triggers off an import through the automated import manager. We have made some significant improvements to the way import works. Right now, we introduced the inspect functionality. We provide more information about changes in your package. Import is skipped for objects that look exactly the same from the source and the target environment. And all the changes have been made consistent and available both in scripts and Appian Designer. I'm sure there have been times when you have exported your patch, you've tried to import it, and there might be some missing precedence, and you don't realize that at that point. You go ahead, import your package into production, and at that point, you have errors, you're leaving your production environment in an unstable state. So we recommend that you test your application package using the inspect functionality. In this way, you can detect any issues early on, and if you have any conflicts with the objects, you can always cancel your import, resolve your conflicted issues, and go back and re-import your package. So the grid that you see here is when you run the import from the user interface, from the browser. So you hit inspect. So you get two high-level statuses: the conflict detected and the success. Success will add all newly added objects into your target environment. Changed is all the objects that will be updated into your target environment. And not changed is when the object look exactly the same between source and target environment, in which case import is skipped. So you're optimizing your import and reducing performance overheads. With the conflict detected status, this is really useful because there are often times when you have objects that are in conflict with the target environment. So this helps you cancel your import, look at all the objects that are in conflict, resolve those changes, and rebuild your package. This functionality, combined with the fact that patches persist, make the whole process of resolving your conflicts and rebuilding your patches much, much simpler. With that, I'm going to hand it off to Mike to show you how to automate the testing process.
Right, so now that Shwetha has walked us through how to automate our imports, the next key step is to automate our testing. And this can still be driven through a CI tool such as Bamboo or Jenkins. And there's two types of automated testing we're going to go over today. We're going to go over automated functional testing, and we're going to go over automated unit testing. First, I wanted to go over the automated rule testing application. So what this does is this gives you a way to visualize the unit tests you've already built for your expression rules. And one thing I want to challenge teams to try is to build a unit test for each of your expression rules. The beauty with doing that is when you go in to enhance an existing expression rule, what you can do is you can verify that your new functionality doesn't break the existing functionality. And then when you add new functionality, you should add new unit tests for that new functionality. So in a way, your unit tests are serving as a specification for your expression. You run the automated rule testing application, and you get a visual on what percentage of your test cases are passing after each deployment. Another thing I wanted to point out is, okay, this is a visual. I can manually inspect this, but how do I automate it? Good question. So what we have here is we have a web API that you can invoke, and when you invoke that web API, you can tell how many test cases pass. It's a XML output, and then you can see whether the overall test run was a success. So the automated rule testing application is available as a shared component. It's also available on the app market, so you can get this application today and start running your unit tests through the automated rule testing application. Okay, next. Automated functional testing. Fitnesse, it's not a new tool. Some of you may already be familiar with it. What it does is it provides a framework for writing test cases in an English style or a wiki style format. And the key advantage to this is that business users can actually write these test cases in a friendly wiki language. And one thing you can do is you can do a form of specification by example or test-driven development where you write your functional test cases before you even build the functionality. So that way, as your test cases are 20% complete, 60% complete, and 100% complete, you know you have the corresponding amount of functionality built in your application. Another thing that I would challenge you to do with Fitnesse is to actually build your sprint demos in Fitnesse. That way, when you do subsequent deployments, you can ensure that by running these automated test cases that new functionality doesn't break an existing sprint demo. Now, I understand you'll get feedback from end users. You're going to change your interfaces. So the idea is you update the spec by example in this wiki format that Fitnesse provides to update the test case. So here's a sample of what a Fitnesse results page is going to look like. You're going to see red for test case failed or green for test case passed. I mean, it's very binary. Either the test case passes or the test case fails. And you can build an interface like this for all of your forms, all of your UIs. And this is going to work on Chrome, Firefox, and Internet Explorer. And since the base Fitnesse is an open source application, we do rely on the Fitnesse open source community to maintain this. And I would say that Chrome is the most reliable of the three browsers. So let's bring this all together. So we learned about automated import. We learned about automated testing. How do we orchestrate this through Jenkins? I'm going to take you guys through a demo. Micro. So first, a developer is going to export and download an application. And each of your developers is going to have a local Git repository where they're checking in code into version control with the version control tool that Shwetha described earlier. So we're going to download it, we're going to replace the existing package, and we're going to run the command line script, the version control tool, to push this to Git. Now, for the purposes of this demonstration, I'm going to manually kick off the build through the Jenkins UI, but you could just as easily have Jenkins monitor Git, Bitbucket, or Subversion for changes, and then kick off a build when the developer pushes changes. Contrast this to the traffic jam we described earlier, where developers manually exporting and manually importing into the target environment. I mean, that's not a repeatable and reliable process. However, this is because you're doing the same process for all of your environments. So next we're going to kick off a build, and that's what's going to happen is Jenkins also has its local Git repo, and what Jenkins is going to do, it's going to build an application package, and it can take, for Git, for example, a start hash and an end hash, and it's going to build an application package that contains those contents, and it's going to push them to your target environment. And you can actually check the status of that build. You can look at the console output for the status of that build. And one thing I wanted to point out is the password's obfuscated here. So a frequently asked question that I get is, okay, I'm using this automated import manager and it wants a clear text password on the command line. If you orchestrate this through Jenkins or Bamboo or another tool like we recommend, you can obfuscate the password. So the next thing I want to point out, you can see that it's inspecting and importing the application. So this is not Jenkins magic. We're simply executing and invoking these tools on the command line that Shwetha talked about later or earlier. And these are tools we've had in the product for a while. Not new functionality, but again, we wanted to make sure everybody was aware that this could be done through Jenkins. And then you're going to get a message that it's complete. So the inspection is complete. Now it's importing the application. It's telling you where the log file is. Next, we're running the unit tests. So the unit tests that we're running are the same unit tests that we ran through the automated rule testing application, but this time we're just invoking the web API that provides. And then you're going to notice in the output, and this is the response we get from the automated rule testing application that, hey, this test case passed, and it's going to tell us that the overall build was a success. Okay, so let's recap what we just saw. Okay, so first step is a developer pushes their changes into Git. This is a Git repository that exists on their local laptop, and this works for cloud, right? Because I'm not downloading it to a cloud machine or a cloud EC2 instance. I'm downloading it to my developer laptop, and I'm pushing this change to Git. Next, what Jenkins is going to do, it's on a separate machine, right? It can be anywhere. It can be on the cloud. It can be on premise. It's what you decide. It has its own Git repo, its own Bitbucket repo, its own Subversion repo, and it's listening for changes. And it's going to notice that you pushed a change to Git. But again, for the purpose of this demo, we're just going to kick it off manually. And that's where it uses the version control tool to build a package. And it can build the entire package of everything that's been checked in the history of that application, or again, you can provide specific start and end hashes for Git. Next, what you can do, you can look at the build history. You can see whether a build passed or failed. If a build failed, you can go into the output and see, why did this build fail? Did it fail on inspect? Did it fail on import? Did one of my automated test cases fail? And that's all going to be in my build log. And I get a notification as a developer if that test case passed or failed. And so what we're trying to do is shorten the amount of time it takes to do deployments. We're trying to increase the reliability of our deployments by taking out the human factor. Okay. So I wanted to talk about the release cycle. So now that I have more frequent deployments, I'm getting functionality to production much more frequently. What can I do? So I want to remind you that Appian provides data metrics logs where you can look at your usage data so you can see which interfaces end users are actually using and working with. And you can take that data to focus on the interfaces that end users actually use. And if they're not using interfaces we expect them to use, you can find out why. You can contact those end users and gather feedback and make your investment based on that. The other argument I wanted to make during this presentation is that since your deployments are easier, you're going to do them more frequently. If you recall the scenario I described earlier where I was on the 8-hour conference call, that was painful, and I'm not going to do that every other week. However, if it's this simple, I'm going to do it more frequently, and I'm going to get more frequent feedback from my end users. So that way I can course correct sooner and provide greater business value in a shorter amount of time. Okay, So Shwetha, want to give an overview of what we learned?
So we define DevOps, all the pieces that make up DevOps, continuous integration, continuous deployment, and continuous delivery. We then built on the survey application to take you through the process of using continuous delivery through the build, deploy, test, and release cycle. And we showed you how we use automation tools to automate the deployment and the test phases. So with that, how do we help you get started? Well, first, we recommend that you check out the Appian Playbook community for some good content on best practices. There are some articles on automated testing and automated delivery using continuous integration. So you be sure to check that out. We also have some related breakout sessions. If you're free this afternoon, you should check them out, some around scaling agile and integrating Appian Cloud with your business and IT operations. So with that, we are going to go over some frequently asked questions. We've curated some that we've received over the last couple of years, and we're going to go over some of them. So can we use Tool X instead of Fitnesse, Git, etc.? Yes, SVN and Git are supported for version control, Selenium and Cucumber for testing, and you have GitLab, Bamboo that can be used instead of Jenkins for orchestration. Mark, would you like to add anything on that?
You're right, so just some color from the field. Even though you can use Selenium, Cucumber, HPQLM, Rational Robot, the advantage with using Fitnesse for Appian is it provides an abstraction layer or a layer of abstraction between Appian and Fitnesse, and that's a layer of abstraction that Appian maintains. So when Appian upgrades and the text field component slightly changes, Selenium or Cucumber may not be able to find that field. So your test team would be responsible for maintaining that abstraction layer. However, if you use Fitnesse for Appian, when you upgrade, Fitnesse for Appian is going to have the latest supported abstraction layer for Appian. So that way you can run a set of regression tests after an upgrade to ensure that the functionality expects as you behave, or behaves as expected.
Thank you. So what are some of the best practices to achieve continuous integration, continuous delivery? Well, practices vary by organization. We have picked some good practices which we could go over. We recommend that you start simple, especially if you're starting out with DevOps for the first time. Make sure you write your automated tests as you design, so when it comes to deployment, you have fully functional tested code. Make your database scripts executable and make sure you consistently collect usage feedback and do that early on as well. Anything you'd like to add?
Right, and I think the key is to start simple. I think the same agile principles apply to IT operations. You don't want your IT operations team to disappear for 6 months and hopefully come up with this, right? I'd say start simple, start with doing your sprint demos in Fitnesse, or start with writing for new expression rules, unit tests for those expression rules, and visualizing those with the automated rule testing application.
So what would a typical team structure look like if you're incorporating this DevOps? Well, again, use what works for your organization. We have identified one example where you could have a delivery team that designs and packages your applications and writes all the tests. And you have your product support team that could support and maintain that automated infrastructure.
Right. I think a key point here is that DevOps doesn't mean no IT operations team. I got a similar question last night. You're going to have an operations team, but they're going to work on more strategic, smarter functionality. They're going to focus on automation. They're not going to focus on manually importing the application. They're going to work on making you more efficient.